course should be open. If it's not, please let me know. Those of you who have computers. I opened it the day after the exam. So what we're going to look at today in our final module is reliability validity concepts. So we're going to take what we've learned thus far about how important it is to have reliable and valid tests, and you've learned strategies in how to write items that are reliable and valid, right? We've learned the test-taking strategies. So now we're going to look at statistics that give us some indication on whether or not those standardized tests are reliable and valid. If your school is going to invest that much time and money into giving the ACT plan, it should be reliable and valid, right? And everybody say hello to my evening class. Hello, evening class. We are recording for them. And you're not going to be in the recording, so don't worry. If you ask a question, I'll repeat it so she didn't have to put the camera on you. How's that? So you don't have to worry if you don't want to be recorded. It'll just be me. It's for that evening. What we're going to look at, again, is Module 4. So I'm pulling up Module 4. Module 4 does begin, like the other modules, with the study guide. That'll be one of the first things you'll want to download. And I want to look at this PowerPoint on scales of measurement. This is to look at how we use numbers. Once we look at the scales of measurement, we'll talk about how it applies to reliability and validity. There's 4 different ways that we use and manipulate numbers. Aren't you glad there's not 40? Yeah. And do you think that would make for a good matching item? Match things with 4 different things, it does make for a good matching item. So look for a matching item on the last exam to cover scales of measurement. The scales of measurement are in hierarchical order. In other words, they're from the least complex to the most complex. So we're going to start with the simplest way that we use numbers to the most complex way that we use numbers. If those are the 4 scales of measurement, the 4 ways we use numbers, what is the least complex? Exactly. And the most complex? Ratio. So nominal is the least, ratio is the most. Simplest to the more complex. Let's start with the simplest way that we use numbers. We use numbers to assign categories. And it's that simple. The nominal scale is the naming. Think of the word naming when you think of nominal. When we give a category a name by numbering it. So if I did have males in this class, I could say group 1 will be all the males and group 2 will be all the females. And that's all it is. It's the naming measurement, scale of measurement. So when we think about numbers and how we categorize them, it does go from categorical to continuous. And the nominal scale is categorical. So we're going to go from categorical all the way to the most complex, which will be continuous. So far, so good. Questions about this? What's an example that you can think of that would be a nominal scale of measurement?
Yes?
Would that be doing things like categorizing
If you use absolutely, if you said group 1 will be our mammals, group 2 is going to be our amphibians, group 3 will be, so if you are simply using numbers to describe a category, you've got the nominal scale of measurement. Absolutely. Good job. All right, let's look at the next. Why do you think they say you probably shouldn't use math with a nominal scale?
Because it's representative. The numbers represent categories.
Right, the numbers represent categories, is what she said. It would make sense to say, well, 2 is twice as high as 1, so females must be twice as good. Unfortunately, we can't say that with a nominal scale. These numbers don't represent anything quantitative. They're simply representing a category. So, not really advisable to use math or statistics with a nominal scale. Let's look at the ordinal scale. Remember I said it goes from categorical to continuous. We're not to continuous yet. We're almost there. Halfway between categorical and continuous is the ordinal scale of measurement. We are now measuring. Numbers do represent a measurement, but it's representing a rank rather than a quantity. So we're not talking about how much, but whether you're first, second, third, fourth, or fifth. So you're ordered. So think of, with the nominal scale, we're remembering naming. With the ordinal, think of the word what? Ordered or ranked. So if I was a health and wellness teacher and my students run around the track a couple times, and the first person that finishes, they get a rank of 1, the next person gets a rank of 2, 3, 4, then I'm using the ordinal scale of measurement. So let's look at these numbers. This is person that got first place ran at 4 minutes and 52 seconds, and that equals 201. Is the 4 minutes 52 seconds or the 1 the ordinal scale of measurement? The 1, exactly. Not the time. We're going to talk about what time is soon. But the 1, 2, and the 3, this is the ordinal scale of measurement. When might we use the ordinal scale of measurement in education? Yes? Yes?
We get a rank in class, in your class, like in high school, or it's you rank first in class.
Exactly. So when they determine who the valedictorian is, that's exactly what I was thinking of. She read my mind. When they determine who has the highest GPA, they're ranking students according to. Yep. Good one. All right. Let's look at the next. And I do have this comment that competencies are not equally spaced. What do I mean by that? How many seconds difference between the person who was first in the race and second? 9 seconds. Nice. How many between second and third? 4 seconds. The next one might be 10 minutes, right? If all we saw was the 1, 2, and 3, we did not see the time, we would not know how different each ranking was from one another. And we could not assume that the difference between the rankings was equal. We could not say a rank of 1 is twice as fast as a rank of 2, right? Make sense? So there's special math that we have to use with the ordinal scale of measurement. There's special math that has to be used because the spaces aren't equally spaced. And that special math is called the Spearman row. Guess what the last name is of the man who came up with this special math? Spearman, yeah, a man named Spearman came up with this statistic. And he said, when we have ordinal data and we want to determine if there's a relationship, I'm going to create a statistic that will tell us that. So the Spearman row is used when we want to know if one ranking is related to another. We want to know if teachers are asked to rank the most important issues in education, We look at those rankings and we ask the general public to rank. We might want to know, hey, did the teachers and the public, are they related? Can we see some similarities here? So whenever we have ranked data, we use something called the Spearman row. This would be great matching. Which scale of measurement is used with the Spearman row? Ordinal. Very nice. Good. The interval scale is what you are most familiar with when we're talking about data from tests, because the scores have equal distances between them. For example, took your third test, it was worth 100 points. What is the difference between 100 and a 99? 99, 98, 98, 97. If I went all the way down to 1 and 0, you would tell me 1. Can I say that a 100 is twice as high as a 50? Absolutely, because the competencies are equally spaced. So when you have competencies that are equally spaced like that, you have the interval scale of measurement. And notice now we are continuous. We've gone from categorical to almost continuous, now to continuous. The competencies are equally spaced. Does it make sense that we can do all the math we want? For the test that I gave you, could I calculate a mean? Mean, median, mode, standard deviation, all that good stuff? We can do all the math I want with continuous data, with interval data. So, now, example of interval data. Grades on a test. If you are just reporting how many they got right, then you are reporting interval data. Questions so far? To the last one. Again, aren't you glad there's not 40 of you? The last one is ratio. Oh, forgot about the man. Guess what the name of what the man's last name is that came up with this statistic? Pearson. So Mr. Pearson said, yeah, it's great that we have the Spearman row for ordinal data, but we need a statistic that determines relationships with interval and the last one ratio. And the Pearson R is used with those two. So if I were to ask on a matching item, what is the lowest scale of measurement that can be used with the Pearson? Well, they're in hierarchical order. Interval, because interval is lower than, the highest one is ratio, right? And then what is the highest scale of measurement that we can use with the Pearson? Ratio. Makes sense? Questions there? So the ratio is also continuous. So since it is continuous, tell me, are the competencies equally spaced? Yes, they are equally spaced. It is continuous. We can say a 100 is twice as high as a 50. We can do all the math we want. Mean, median, mode, standard deviation. So what's the difference? Big difference. The ratio scale has something called an absolute zero. And an absolute zero is not what you think of when you think of a zero. An absolute zero is something that cannot be recorded in the grade book because it means absence of whatever it are we are measuring. Absence of the variable. So zero doesn't represent a grade. With the interval scale, what does a zero represent on a test? Student didn't get any right, correct? In this case, zero represents you haven't started measuring anything yet. Absence of what you're measuring. See the difference between the two so far? Let me give you some examples. If you have a scale to measure your weight, What does it start with? 0. But can you ever weigh 0? No. Can't weigh 0, right? Can't do it. Yeah. So why does it start with 0? You can't weigh 0. It has to start somewhere. So 0 represents absence of weight. The scale is saying I have to start somewhere. I'm going to start with 0. You haven't put anything on me yet, but as soon as you put something on me and step on me, then I will be above 0. So that is an absolute 0. When we're talking about 0 represents a starting point or absence of weight. What about height? Can we ever say someone is 0 high? No. So the ruler starts with 0 because, again, we have to start somewhere. But 0 represents you haven't started measuring yet. Why is response time a ratio scale? If we are measuring how fast someone can do something, why would I consider that ratio?
Because you don't start the counting of time until they respond.
Right. But your stopwatch starts with what? 0. But as she says, we don't start counting the time until we hit the button and then seconds go off. We will never be able to say, well, you completed that task in 0 seconds. Even if it's 1/1 billionth of a second, time will go by as soon as you hit the stopwatch, even though it starts with 0. Questions about interval and ratio? All right, well, I have some questions for you. Track coach is recording in minutes and seconds how fast the students can run a mile. Scale of measurement. Ratio, okay. Why did she say ratio? Just give it a try. Yes. Because we know that the stopwatch will start at 0. But if I'm recording how fast someone can run a mile, will I ever be able to record to 0? No. Can't do it. But there is equal distances. The distance between 1 second and 2 seconds is the